So this video, this lecture is really would be two lectures. So it's going to be very long, but it's essentially two lectures of class time. So we're going to work out very carefully a lot of chain rule problems, okay? And again, I think if you practice along with me, you should be fine. I want to again emphasize the chain rule. Again, you're talking about functions of a single variable, but notice that the functions, the composite functions have different variables. So if you're talking about the chain rule, the function h is a composition of functions. Now this is just my notation. I like to call it out this function h equals f of g. Different people have their own style, call them different things. But for me, h is the composition of f and g in this form. If you have it written in this form, its derivative is this. So notice the derivative of this function, right, involves the derivative of each of the constituent functions. Okay, and we're just going to work it out carefully. Now the real problem here is how do you guess the functions f and g? And we're just going to be very careful about this. So here's our first practice problem. Now notice if you wanted to, you could just multiply this out 3 times and it would just be a 6th order polynomial. But that's a lot of algebra and really maybe not the best way. So I'm telling you the function h and I want to find its derivative. So again, here it is. I'm just trying to emphasize, again, I wouldn't make a big deal about it certainly on tests or anything, but you have different spaces, right? X goes into Y, Y goes into Z. Again, you look at this and you say, is there anything I can do in a preliminary step? And yes, here you could just multiply it out 3 times, but it's a lot of work and risking algebra mistakes. So let's just look at it as a chain rule problem. Again, how do I know it's a chain rule problem? Well, look at the rules on the crib sheet I gave you. Not a single rule except the chain rule applies to this rule. So you're stuck with it. If you're going to use the chain rule, automatically you have to come up with the functions f and g, and you have to guess. But it's a little easier now. We can do this, and you'll get the hang of this pretty quickly. Now look what I have. H is a composition of f and g, right? That's the generic form, and this is my specific rule. So if you look at that, I'm thinking, what is g? I mean, look at the picture. What is g? I'm just g of x. This is why I like the notation. G of x. What is the x stuff here? Right? I mean, you could say 2x. Now, g of x is the inside. It's inside the brackets. Take the x stuff. Now, occasionally you'll see we get to problems and you do have some choice. It works with either choice. But generally speaking, you don't have a lot of flexibility here. Take g of x to be the x stuff. Right there, g of x is the x stuff. And again, eventually you can do this in your head without any doubt about it. But I'm going to put down all the steps and I'm going to be consistent about it throughout. Now again, this is where the variables come in. Y is g of x, right? I mean, this is the composition of functions. So, well, that's y, right? Y cubed. And so what's my function f of y? Right there. And they'll all break down like this. Every single problem will break down. So really, chain rule problems, the real challenge is find your functions f and g and then just go. Again, fight smarter, not harder. The derivatives should be straightforward. Here's my function f of y. Here's my function g of x. Again, single variable calculus. But notice the variable differs. This is a function of x, this is a function of y. It's never a bad idea to check to make sure you did make the correct choices. And I'm going to emphasize that because sometimes you get sloppy if you mess it up in the beginning. I mean, you don't necessarily have to write it down, but you should run it through your head. It's just good technique that you did it correctly. All I'm doing is replacing gx by its rule. Now I have to evaluate this. Again, think about it as a box, right? This variable y is just a placeholder. It's a memory location, right? Again, this means exactly the same. It's perfectly acceptable. Maybe it's not standard, maybe it should be. But whatever goes in that box, right? Whatever goes in that box gets placed over here, and that's it, right? So it checks, right? Everything worked out, so I'm good to go. Right, that's the idea. All right, so now I have the function f and g, and I guessed. For the chain rule, I need their derivatives, right? Here's the chain rule. And you can see I need the derivative of the function fy, and I need the derivative gx, right, in order to apply the chain rule. So here's my function f, here's my function g. Again, usually, I mean, they're pretty straightforward. It is possible that they can get chain rule on a chain. We'll just deal with that when the time comes. This should be a straightforward derivative, right, just as we did before. This is the straightforward derivative. The function g goes in, apply the differential operator, gx comes out. And we just substitute in. Here's the rule. Again, I'm not going to write everything out quite in the form I did before, and eventually I'll just write it down. But that's the function f, that's the function fy. Same over here, that's the function g. Just apply the steps, difference rule, take out the constants, power rule, etc., etc., etc. Okay? Again, for a straightforward problem like this, I'm not suggesting that you have to write it all out. I'm just trying to emphasize there are rules, and it does follow a methodical process. Again, later on when the problems get a little more involved, I'm just going to say the derivative here is 3y squared, derivative here is 2, right? But I just want to emphasize to you, there is a methodical process. You are always following the rules. It's not a mystic experience, right? This is math. So that's it. I mean, that's enough, right? I mean, that's enough. So I have everything I need to apply the chain rule. Right? So I'm just listing my data up here. Here's the chain rule. And again, so we want the function hx. The function h goes in, apply the differential operator, and the function hx comes out. Again, every problem I'm going to emphasize, you don't have to write this. H is a composition of f and g. For it to be the chain rule, you have to have h as a composition of f and g. And by applying the chain rule formula, I have this. Right? That's just a chain rule formula. Okay? Again, you might just start here. I'm just saying, though, that you should always understand that you're talking about composition of functions. And at this point, I'm simply going to plug in the data. Right? Gx equals 2. That's what we obtained. Just plug it in. Gx, right? We have that as well. That's 2x minus 7. I just plug it in. Now I have the function fy, right? That's here, fy. So I'm just going to evaluate this, right? 2x minus 7 goes in the box, right? So I'm just going to plug in 2x minus 7 directly into the box here. And there you have it. I mean, there you have it. And now, I mean, okay, we can clean up some of the algebra and we're done. Right? We're done. So if my original function was 2x minus 7 cubed, the derivative is this. And we're just going to repeat this pattern over and over. And all it's going to happen is, okay, the functions get a little more involved in this and that. And that's fine. Okay, now here's another one. Okay, now again, if you look to this function, let's look at our preliminary step. I did this because I want to emphasize a little bit on this domain. Right. Again, I want to get rid of the power. And if you look at this, I'm setting this up to be standard form, right? I don't want square roots. I want things to look like powers, sine, cosine. We'll add other functions to the catalog later, but okay, that's it. I can't just apply any rule on that list, right? Look at the crib sheet. I can't apply any rule directly to this. I mean, you can't apply the power rule to this because it's not x to the 1/2. So the only rule that applies is the chain rule. Okay? So I'm stuck. If you're going to talk about the chain rule, you have to find functions f and g. You have to. I mean, even if you're applying a blanket rule and you were forced to memorize them, you're implicitly guessing the function f to use those rules. So try to guess the rules f and g. Okay, let's try it. Again, use a process here. Here's the generic sense. H is a composition of f and g. Here's my specific rule, right? Here's my specific rule. Okay, so what are you going to take gx to be? Right? Take gx to be, well, the stuff inside, the x stuff. Right? Take gx to be the x stuff. And then, because of composition functions, gx is y. I'm just going to apply that up here. Right? And there's my function fy. And there you have it. There's my function fy and my function gx. Now, where I differ sometimes in the books is a lot of people like to call, instead of y, u. Okay, I can explain it, but whatever. It's just your choice. I like x, y, and z, h equals f of g. I mean, that's just what I prefer. Other people, have their different choices, right? And one thing I don't like is I don't like calling this function the same as this. So I wouldn't call this u equals ux or, okay. So I'm just very careful about this. Again, if you're a pro and you've been doing this a lot, maybe you're comfortable with these notations. But I'm just going to be very careful and precise about how I do it. So anyhow, I have my functions f and g, and they came about just using this manner. And it's a good idea to check. Again, I'm talking about composition of functions. I'm going to substitute in the g. Right? Literally, you just cut and paste the rule over the name. And then I'm going to evaluate f. Again, it's just a box. The y is just a slot. Something has to be put into y. It's a box. And that's it. And you see that it checks. Again, it's just good technique. I'm always going to do this. I mean, you might do it in your head, but you should think about it. So now once I have my functions f and g, notice if I want to apply the chain rule, I need their derivatives. I need the derivative of f, and I need the derivative of g. Right, that's what I'm looking for if I'm applying the chain rule. Here's my function f, here's my function g. I just need their derivatives. F is a function of y, so notice that all the tags here are y. G is a function of x. Again, all their tags are x. I'm just plugging in, power rule, right, algebra done. Same on the g side. Right, just plugging in difference rule, powers, done. Okay, so here's the short table. And again, I'm not against, if you're comfortable with writing that down directly, that's fine. Again, I'm not against shortcuts. Just understand the more you shortcut, in my mind, the greater probability of making a mistake. Right, so that's the issue. I'm not against shortcuts. But be aware, the more you're shortcutting, the more you're risking making a mistake. Okay, I have my data. I just need to go and plug it into the chain rule. So I'm just relisting the data up here. Again, this is what I want. I want the derivative of my function h. So if the function h goes in, I apply the differential operator. Again, I want to remind you that we're talking about the composition of functions, and that's why the chain rule comes out in this form. And at this point, I'm just going to substitute in my data. If you haven't done it, pause and do it. Again, try to work these with me. I'm substituting my gx. I'm going to substitute in my g. Right? And now I have my function fy. I'm just going to look at that. And that's a box. Like I said, y is a container. Something has to go in there, so maybe that's a better notation. But x squared minus 1 goes in the box here, so I'm just going to plug it in here. Right? And that's my expression. I'm going to put that down in there. And then we simplify. I'm going to move, again, I'm putting in the algebra steps. 2x goes to the top. 2 over 2 is 1. That's how things cancel. Be careful about that. Again, these small algebra mistakes, people make a lot of algebra mistakes. You just have to be careful. So here's my original function h, and here's its derivative. Okay, let's look at another one. You'll start to see there certainly starts to be a flavor about these. You start to recognize that the same things keep happening, and that's good. So, okay, write this down. First of all, try to put it in the standard form. And if you want to go further than that, then that's fine as well. But pause, and I want you to work these out. Okay, let's look at the function. You have x plus 1 here, so x greater than minus 1. right? So again, this has to be, can't be 0. Square root has to be positive, so x greater than -1. This isn't in a good form, right? Well, this tells you x plus 1 has to be greater than 0. Again, what I like is powers. You're always looking for constant times something power, constant times sine, constant cosine. We'll add, again, more functions to that list. But they're all going to work the same. You're looking for certain prototype ways of dealing with it. Okay? So this is what I'm really looking for. Now again, on an exam, I wouldn't waste the time on this, but you should be aware it's there. It's an error protocol in the code. You should be looking for that. Okay, now, if you look at the rules to differentiate this, what rule can it be? Again, look through the list. Just it's a checklist. It's not going to be the constant rule. It's not the power, The only rule that would work here would be the chain rule. So if you're going to use the chain rule, necessarily you have to come up with the functions f and g. So try that. Try getting the functions f and g. Okay, pause, try to get it. Okay, so because I'm using chain rule and there's no other choice, I have to get f and g. So let's look at it. Here's my general form, here's my specific form, my specific rule, right? What's going to be g? What's going to be g? Again, eventually, even maybe now you don't need to write this out, but again, know the technique, so if the problems get more challenging or you're a little surprised, you still know what you're doing. So g is just going to be the x stuff in the middle, right? Just the x stuff in the middle. And again, by composition of functions, the output of g is y, in my notation, y. Okay, so I'm just going to go up here and substitute y, and that tells me my function. Right? I have my function. So again, I have my function fy, f of y, and I have my function g of x, and I'm good to go. Now again, I'd like to encourage you, check your work. We're looking for composition of functions, substitute in the g, right? G goes in is what's in the box, so that's f of y. Y is just a placeholder, right? It's just a box. So the x plus 1 gets plugged right into that box, and that's how I get the rule. And it checks, so I'm good to go. Again, it's a nice way to see if you've made any kind of a, if you will, a dumb algebra mistake. It's just a good check on your work. Okay, here's my data. Here's my chain rule. So we have the functions f and g, so we're going to need the derivatives. Right? So jump in and do that. Pause, make sure you can do this. Jump in. Right? So I need my derivatives. Here's my function f, here's my function g. I just need their derivatives. Again, you could probably do these in their head, but I just want to emphasize that there are the rules, the calculus rules, right? The differentiation rules. That's what I want to emphasize. And I'm not going to not do it just to be sloppy. Later on when the problems get longer, I'll simplify. Okay, so just the standard rules, that's what we have. So to sum up, we just have this. And yes, I accept that it's possible to do this in your head, and that's fine. Really, it only takes a few lines, right, to show all your work. 6 lines. That's fine. Again, I'm not against that. But you should know how you're going to do it, especially when you start getting complicated problems like chain rule and a chain rule, so what? So here's a list of my data, right? So I need the derivative, and again, I'm talking about the composition of functions, so here's my chain rule, so try evaluating it. Plug all your data in, pause, plug all your data in, let's compare at the end. Okay, let's see. I have gx, the derivative is 1, right? That's my data. G of x is x plus 1. And now I have fy from over here, the derivative, right? So here's my derivative fy. Again, y is a placeholder, it's a box, something needs to be placed into that. In this case, it's x plus 1. So there's my expression. And there it is. Now again, at this point, it's just, algebra cleanup. Again, there's not a whole lot here, but again, you're just going to have to practice with that, It just takes practice. So here's my original function, and here's its derivative. All right, we're just going to continue. Now, each of these is getting a little longer. Again, if you look at this, there's no basic rule you can do with this. You're stuck with the chain rule. So see if you can do this one, right? Just give it a shot. Be patient. Just go through the steps. It should always follow the same template. Okay, let me jump in. Again, I like to look at this. I need x to be non-negative because I'm going to have a square root here, but it's in the correct form. I have the powers, right? I don't really want the square root symbols everywhere here. Calculus is not set up for that. It's set up for powers, sine, cosine. Again, other functions will add. Okay. And that's it. And again, since there's no other rule I can use, the only possibility is the chain rule. It's the only possibility. I'm writing this out. Sometimes I see this a lot on the test. This is not correct. Algebraically, these are not equal. Right? And you can see the problem here. If you were to make this algebra mistake, you say, why do I lose so many points? Because you've changed the problem. The problem I gave you requires the chain rule. The problem you gave doesn't. Right? The problem with this kind of an algebra mistake is that I give you a problem on a test. You effectively say, I don't like the problem you gave me. I want to make up a new problem that's easier. Okay, so be aware. This kind of algebra mistake is a problem. If you're making it into homework, that's one thing, right? Mistakes like 2 times 3 is, 5. I don't care. But this kind of stuff, well, in terms of the calculus, but this kind of stuff affects the calculus, so be aware of that. Okay, so if I'm using a chain rule, I have to have functions f and g. So pause the video and try to get your functions f and g. So the issue is to find the functions f and g. So when we look at this, okay, here's the general rule. Here's the specific form of that rule, okay? And the trick is, can you find the function g and the function f? So again, if you haven't, give it a shot. So g of x is going to be the x stuff. Again, it takes a little practice. You might try to think it's x or x square root of x, but again, it's going to be the interior stuff. So I'm going to take g of x to be this, and in which case y equals gx. So that sets up what my function f of y has to be. Again, it takes a little practice, but you'll start to see it soon. Here's my function f of y, and there's my function g of x, and it's just a good habit to check, right? I have composition of functions. G goes on the inside. Just think about cutting and pasting. Of course, that's what I did for the slide. Just cut and paste over the gx. And then again, that's a box, right? The y variable means something has to be placed in there. Right, so these things mean exactly the same, and I'm just going to substitute this into the box, and that's it. Again, it's fine to do it in your head, but you should think about trying to check your work. The key feature, though, if I'm using the chain rule, is that the function's f and g. All right, the next step then should be take the derivative of those functions, okay? So that checked out, take the derivative, right? So the chain rule requires me to have the derivative of function f and the derivative of function g. Okay, so here's your functions, take their derivative. Again, it doesn't have to be a big deal, but just do it quickly and efficiently. Okay, let me show you. I need their derivatives, right? I'm substituting in the value in the rule, function rule, taking its derivative, using the power rule and so forth, just cleaning it up. And on the g side, again, it'll be substitute in the specific rule, sum rule, power rules, and clean it up, and so forth. Okay. Now again, I'm going to put these steps in. Eventually, I'll get to the point where I won't, but I want to emphasize again, there are rules. It's not just just a mystic experience or something like that. So here's a table of data, right? These couple of lines is all you really need. Okay. Now the final step. Here's my data. Apply the chain rule. Okay. So again, composition of functions, here's the chain rule. So if you haven't done so already, pause, plug them in, and we'll check. Okay, let me jump in. There's your function gx. Right, I just substitute that in. It comes from your set of data over here. There's my function g. Right. Now I have my function fy over here, and I'm just going to substitute into there, right? I'm going to just substitute in. Here's my function. Once more, y is just a box. Something has to be placed into that variable. That's what it means. Something has to be placed into it. And that's it, right? That's what's placed in. And so now, again, I mean, you could simplify. You could do things. You can match the answer in the back of the book, and that's fine. Right? It's not bad to practice matching the answer just in the sense of practicing your algebra. On a test, I wouldn't really go through simplifying any more than just the obvious things. So, but again, it's worth practicing for the homework and stuff like that. As I said, you're not going to get better with the algebra if you don't practice. Okay, here's another one, and we'll see that this is getting a little more involved. Each of the problems get a little more involved. So see if you can do it. I'll do it piece by piece again, but jump in and give it a try and then compare at the end and see how you're doing. Okay, so jump in. Okay, we have this. And okay, this is how I have this. Now, again, how would I do this? I need the interior to be greater than or equal to 0, right? And then that's sign intermediate value property on this interior function. Again, I wouldn't do it for the test and so forth and so on. You could just, it's a single variable, you could just graph it. But if you look at the rule as the key, none of the rules work, right, on a crib sheet or whatever. None of these rules work. The only possibility is chain rule. Now again, the square root I don't like, so we got to get rid of that. I want everything to be to powers. But if you look at this, the only rule that you're going to be able to do ultimately is going to be the chain rule. Now you could break this down, put this in the top, put the power in the bottom, but anyhow, you're still going to wind up using the chain rule, right? If you're going to use a chain rule, you need the functions f and g. So if you haven't done that, jump in and try to do it. Okay. Yeah, I've been kind of implying this for a number. I'll just come back and show you. Again, it's not really, you don't have to jump in with this problem, but it's good to see these things. As I say, that's the reason I do it. So you need your functions f and g. So in a standard form, this is the generic form of composition of functions. Here's my specific rule. So g of x is going to be the interior stuff, the x stuff. See, that's why I like, again, I like this notation. The x is the x material, right? The x is the x material. And we know because it's composition of functions, y equals g of x. And so I'm just going to convert this to the y material. It breaks down. Usually there's not a lot of problem doing this. Again, keep practicing it if you're not getting it, and you'll get it. So I have my functions f, and I have my functions g. Again, they're both functions of a single variable. In Calc 3, you'll do exactly the same thing, only you'll have multiple variables. X, Y, Z, maybe time, whatever. So I just get them, and once more, check your work. I don't want to make a mountain out of a molehill, but it's a good thing to check your work and make sure you haven't made any mistakes. It's good technique. Well, this is where I got the domain from. I see H is a composition of these functions. So what do I need? I've just graphed these functions here. Now you'd use sign intermediate value property. You need this 2x over x plus 1 to be positive, greater than or equal to 0. That's intermediate value property. That's your function g. And if you plot it here, notice what goes into the function f, right? F has to be greater than or equal to 0. So I need values of this function g that are greater than or equal to 0. Well, look on the map here. Look on the graph. The values of g, the y values of g, are greater than or equal to 0 for x greater than or equal to 0, and also for x less than minus 1. And that's where we get this. And then, of course, I don't want 0 because I don't want, or what is that? I don't want the bottom to be 0 at any rate. And you can look and see how the graphs connect, right? The function h is the composition. So you give me an x value, you get a y value. The y value goes into here, and that gives me the z value. So again, when it's functions of a single variable, you can draw the graphs. When you're doing multivariable calculus, it's maybe not so easy. Anyhow, let's get back to the chain rule, right? So what I need is, right, the derivative. derivatives. I have the function f, I have the function g, and I need their derivatives, right? Here's my function f, here's my function g. So, okay, take a moment and take their derivative. Okay, well, let me jump in. Again, for f, it's straightforward, right? Just a power rule, right? So again, it's just a power rule. For g, okay, well, if you look at this, it's not as straightforward, but it's just going to be the quotient rule, right? It's just going to be the quotient rule. So again, it's a little more involved, but again, one step at a time. It's its own problem. Just take it carefully, work through it, and you're good to go. I'm just cleaning it up. Again, this is just all algebra. I'm going to get a common denominator here. I'm just putting in all the steps. You can check. I'm just putting in all the steps. And it comes out to that relatively simple expression. I mean, it's a lot of work to get there, maybe. But there it is. So I have my function f, I have my function g, and I have their derivatives. And again, I mean, taking the derivatives, I mean, doesn't always have to be as simple as a power rule. Like in the case of g, you had to use the quotient rule. You might have a chain rule in a chain rule. It's fine. Just break it off and do it on the side. It's its own problem. And here's the data I have. The next step is apply the chain rule. And again, try it. Pause the video, see if you can do it. Okay, let me start up again. Here's my data. Here's my data. And this is what I want. Again, H is a composition of F and G. And this is the chain rule. And you just plug the data in. Again, if you haven't, give it a shot. Okay, I plug in G. GX, I mean. I plug in GX, right? I just have that from my data over here. I plug in G. Again, the expressions are a little more complicated this time, but it works exactly the same way. Again, whatever goes in the box, I just evaluate over here. There's just a box here. I just plug in whatever goes in here into that box. And yes, it's a little ugly. And I mean, again, there's algebra. You can simplify it. I didn't put in all the steps, but I got it to look like this. Okay, I mean, it's a number of steps. I mean, you can practice. Like I said, there's nothing wrong with it. For the exam, I just, I even just leave it like this, maybe cancel out the twos, but you can just play around with it. And I got this. Again, you could write it in different ways. So my input function was this, and my output function was this. And really the feature of this problem was it was just a little more complicated, a little uglier. But it's just still the same process. Okay, here's another one. Now, let's try this one again. Pause the video, give it a shot. Just try to just press your way through this. Persevere through this. Okay, let me come back in here. Here's my function. And again, I want to write it, I want to get rid of the square roots. I want powers. So I have sine, I have powers. That's the kind of thing I'm looking for. And once more, if you just try to apply it to the differentiation rules, the only possible rule that could work here would be chain rule, right? Because you have to have sine of x. Clearly, we don't have sine of x, right? This is a more complicated expression. And this is going to be a bit of an issue. So once you decide you're using the chain rule, you have to define your functions f and g. So if you haven't done it, pause and give it a shot. Okay, let me do it. So here's what I have. I'm going to take gx to be the x stuff. Now, you could take g of x to be x squared plus 1. That works fine. You're either going to put, I'm going to caution, you either put the work on the f or the g, and you'll see I don't want to let the secret out yet. I'm going to take it like this. You could just take it to be x squared plus 1, and you'll get exactly the same answer. So here's a case where you actually do have some flexibility. It doesn't make any difference whether you take it one way or the other. I'm just going to take it to be this. Okay? So if I take this to be my g, then I have for fy just to be sine y. Right? Now again, if you took g of x to be x squared plus 1, you'd have sine y to the 1/2 in here, which is fine. It's fine. You could do that. It's fine. Either way works. Okay, so either way works. So again, you can check, and I just did it fairly quickly here, and it works out. Okay, so again, chain rule. I'm forced to use a chain rule, no choice. I have to pick my functions f and g. Okay, there's a little flexibility there, but now no choice. Everything works out. You have no more choice. So I have f and g. Okay, what's the next step? Take their derivatives. Okay, try it, and I'll do it. Pause. I'll start it up in a minute. Okay, here's my data. Here's the chain rule. I need my derivatives. Again, it's not for a random reason. I need these derivatives. Here's my function f. Here's my function g. I need their derivatives. Okay, so derivative of sine is cosine. No big deal. Now, how about here? Now, you see, this is the issue. One way or another, you're going to have a chain rule and a chain rule. Now, what the students say, do I need to memorize a chain rule and a chain rule? No, I mean, just look. You're either going to have the chain rule on the f or the chain rule on the g. It doesn't, fine. Now, once I get to this point, say a chain rule next page, break this problem off. It's its own problem. Fold the paper in half and just do it as a straightforward problem on the next page. I mean, work smarter, not harder, right? You always should break it down so you're never taking a hard derivative. You're just constantly breaking it down and making it easier. So this is the problem I have. I want to find this derivative. Again, just look at it. It's its own separate problem, right? Do it on a separate page. Fold the page in half. So my function is h. Now, I have to use chain rule here. This is its own problem. How am I going to do it? Chain rule. Right? So I need the functions f and g. So look at it. G is going to be the inside stuff, right? And then f of y is going to be, well, square root of y. I think we've actually done this or something very similar. So here's my function f. Here's my function g. Again, you can check your work, see that it all works out. Now I have my f and g. I take their derivatives. Right? So the one is the power. Notice when you take the derivatives, it's always the basic rules. You're always taking the basic rules, right? Always the basic rules. You don't have to make a mountain out of it, right? It's just this little data up here. Here's my chain rule. Right? Again, I don't know if you need to write it all, but I just plug in my data, right? Plug in my data, right? Clean everything up, and that's it. So at the most basic level, you're always just taking the basic derivatives. It's always a break it down rule, right? Chain rule breaks it down until you're just taking basically these simple derivatives. That's the game. Now once I have this, I'll just go back to my original problem, right? Now here's the original problem, right? Here's my original problem I had. And I just go back now and substitute the data in. If you haven't done that, you practice. Pause and practice it. So there's my gx. There's my g. I have to evaluate f of y. And again, it looks messy, but just follow the steps. The y is a box. Whatever goes in that box, just cut and paste. And now, okay, that's it. The calculus is done. Leave it like that for the test. If you need to simplify it, okay, I just cleaned it up. I put the cosine in the top and wrote the square roots out. But who cares? And that's it. I mean, I'm not saying it's easy. I mean, this was a chain on a chain rule. It gets long, but, you know, okay. Okay, so that's it for these standard problems. Now, the feature of today was that all problems were the chain rule. In the next lecture, I'm going to mix them up. I'm going to tell you to chain rule or whatever. Problems are going to be mixed and so forth and so on. So again, we're going to just continue to practice these problems, okay? All right, good luck with that.